Hello, my name is Arne Döring and I would like to make a small introduction to Emacs. So first of all, to the motivation why I'm doing this introduction. I've never seen an introduction for Emacs that actually describes what Emacs is. I've seen introductions that show you how you use it, and I've seen introductions that tell you how amazing it is by showing you some examples that will hardly convince anybody. So I try to explain the fundamentals and why Emacs is an interesting piece of software. I don't want to say text editor. So Emacs is by heart or in the core a virtual Lisp machine for live coding or live code editing, mostly for Emacs Lisp itself. So it has maximum inspectability, maximum audibility, and it has some form of workshop mentality. So Emacs is a piece of software that you can shape into your workshop that you use every day and make your most versatile tool for your everyday job. And it's not like a pre-configured IDE like other tools that are out there. There are other tools for live coding that exist that I don't have worked with personally. One of them is Smalltalk, and the other one Symbolic's Lisp machines, but they are not made anymore, so I don't know if they are still in comparison. So this is vanilla Emacs. I accidentally clicked a link for coding, so I just close the browser. It has a built-in browser that is questionable at best. And this is the starting page of Emacs. It's really just vanilla Emacs, nothing configured, nothing changed, because when I want to bring over the fundamentals, I want you to see that it didn't change the default behavior. So first of all, I want to open the scratch buffer, so Control X. B switch to buffer, and by default it selects scratch, so that the scratch buffer. The scratch buffer is for Lisp interaction. I can write Lisp code and evaluate it. So in this case I will write a simple addition plus 1, 2, 3. Lisp is a programming language where you write the function name at the beginning, then you put the arguments all separated by a space, and then you surround the entire expression with braces. And that's an expression in Emacs Lisp, and there are two ways to evaluate it. So Control X, Control E will evaluate it and print the result here in the bottom buffer, but that's not very useful, so I'm in the scratch buffer. Much more useful is using Control J, which will print the result in the current buffer. I can do other things, for example multiplication, 1, 2, 3, 4. It will multiply all the arguments, Control J, and the result is 24. More example, concat ABC, 1, 2, 3, and it will concatenate the string. So I won't do Emacs Lisp tutorial, but if you want to experiment with the language, this is the best place to do so. One side note though, if functions have a side effect, they will change the state of Emacs itself. So by evaluating functions, you can technically break Emacs its own, or you can disable functionality and make it completely unusable. So you have to restart it. But it's also very useful to modify the behavior in the way you want to, or experiment with stuff. It doesn't happen too easily that you break stuff. Then the next part I want to talk about is inspectability. So Emacs is really optimized to inspect everything all the time. So you can inspect the state of variables, you can inspect what functions do, what functions exist, and how to call them, and you can inspect key bindings. So first of all, with the help key, it's either Control H or F1. So I press F1. Then I can get help for a list of things. So I press question mark as it says so for further options. It says what options do I have, and I press B for all keyboard binding, for all key bindings. So this will show all the key bindings that are available in the Scratch buffer. Most of these key bindings are there for Unicode symbols, so that's why there are so many. But there's also a lot of functionality for text editing and cursor navigation. Then let's do another thing. Help F for function, so describe function. I have to enter a function name that I want to help with, but I don't know which function I want to help with, so I press tab. So I get the list of functions available, and we already see the plus. So I can write plus in here and say I want the documentation about the plus function. And here it says the documentation of the plus function, and returns the sum of any number of arguments which are numbers or markers. So here we have important information that plus does not only allow number arguments but also marker arguments. I won't go into detail what that is. Next thing about help, what is very useful is inspecting variables. So F1, V for variables, and then I can again do completion. Basic display. How about that? Emacs. I don't know what that variable does. Emacs basic display is a variable defined at startup. Its value is no documentation. Okay, bad example, but very friendly for exploration. So much for customization. The next thing is customization. So I can set values, for example, Emacs basic display. I don't know what that does, but I can set the value for that. I hope I don't break something. So I've now set it. I go back in this, I press G for refresh, and it says, now it's set. So I can change the state of Emacs itself at any time, wherever I am, whenever I want to. Then I can define my own function. For example, I define my own function, call it, I define it with defun. So for define function, I call it insert JJ, no arguments. I say it's interactive. In this case, I want to be able to bind it to a key, so it's interactive. And what should I do? It just inserts 2Js. So now I evaluate it, and now the function symbol is defined. Now I want to map it to a key, so I do local set key so that this key binding isn't set globally. Keyboard J, just the letter J will have this functionality, and then I pass in the function symbol and evaluate it. And now when I press J, it complains. Wrong type argument, Command P insert JJ. Did I do something wrong? Let's see. This works. Insert JJ. Well, I had a typo in here. So let's redefine this function. Now it works. the way it worked, even though I've redefined it, is I've passed in the symbol insert JJ, and that's basically a name. I've just passed in the quoted name of that function, and this quoted name can also be defined afterwards. So it has a reserved name in there. Next thing in my list of customization. Oh, yeah, then I want to talk a little bit about the type of programming you can do in Emacs Lisp. It's somewhat called buffer or mode-oriented programming. So it's not object-oriented programming. It's not, well, it's not really functional programming, and it's also not really object-oriented. It's buffer and mode-oriented programming. So in object-oriented programming, you often create a class with members, and this class is instantiated whenever you need to do it. And in Emacs Lisp, when you want a similar behavior, you just define variables and say that they are buffer local. Buffer means this scratch buffer is a buffer, this help buffer is a buffer, and when a variable is buffer local, when I set it, the state is just set for that buffer. And that is the instance of that variable. And using this substitute most uses of instantiating something in the Emacs domain. So you just associate your variable with a buffer by saying it's buffer local, you have a state per buffer, and that's a way of programming. So, and when you want to instantiate something, you just create a temporary buffer, or you work with dynamic scoping in that case. More classic object-oriented style programming is still possible. There are macros to do object-oriented style programming, but I've once seen a program that did it, and the syntax of Lisp is not really good for object-oriented programming. So it's basically non-existent, but possible. So that's my short introduction of Emacs. I hope it helped you to understand a little bit of the functionality, and now I want to show you a few neat features that are in Emacs that I didn't see in other editors. I will just show two things. One is the occur mode. For example, when I have more defuns, that doesn't do anything. I have another. And I want to see all versions of defun. I can, first of all, I can search things with meta or alt S and then dot, then it searches for that thing, control S for the next, and control R for the previous. So reverse. And when I want to see all occurrences of that word in the current buffer or current file, I can press Control Meta S O from here, and now I have a buffer with all the occurrences that I can click, and it's associated. So I can, even when I'm editing in here, I can navigate to all occurrences that I found like this. And that's a really nice way to mark or notify myself that I want to operate on certain things, and I can then jump through the list of things that I've previously marked. By the way, that also works with regex search. And the other thing I want to mention is compile. Sadly, I don't have a good example. Compile I can call with Control X compile, that it will ask me for a command to execute. In this way I will just say make, and it will fail to do so. And then it will create a buffer, a new buffer, and print all the error messages in here. And the nice thing about compile is that when you have, for example, GCC running in compile or some other thing running in compile, there will be a regular expression that matches the error messages from that tool that you've run previously and make them clickable. So it will pass the error message and the line, and then from your text file you can then jump to the error messages. You might argue that in the domain of IDEs that have much better tooling, this might be out of place, but you should not underestimate the simplicity of this tool. You just run a command line argument, you can specify regular expressions to match on, and you already have your Emacs integration that works with not only compile errors, but also with stack traces. So when you run your own program through the compile command and your program crashes and it prints a stack trace with file and line information, this stack trace is then clickable. And that is a big advantage that many IDEs already don't give you. You have to use a debugger to have useful stack traces. Okay, that's it. Now I want to come for the end a bit of bad stuff about Emacs, and that's basically Emacs is arcane. It's old software, and that has its own thing. I don't know when it originally was created. I didn't write it down for this introduction, but it's very old, and many decisions had to be made before conventions were a thing. So it has its own vocabulary. In Emacs, a buffer is what you would call like a text page or something, or file content in other editors. A mode you would probably call editor plugin or something, but it's complicated. Frame is window, window is frame, kill is cut, yank is paste, meter is alt, and font lock is syntax highlighting. And it has arcane usage. For example, Control Y is used for paste and Control W is for cut. And when you want to save it, you press Control S. It does not save, it actually starts search, your interactive search, and that can also be very frustrating. But that being said, I think it's a very cool and interesting program, and maybe something you might want to investigate a bit. Okay, that's it. I hope you liked the video.